In this video, we're going to be going through the May-June 2024 paper 11 question 7 problem. And just to jump straight into that, the question says, in the diagram, AOD and BC are two parallel straight lines, right? So we want to highlight as much of this information as we can as we read the question, right? So we have AOD, which is this line from this end right up until the end here, and BC are two parallel lines, right? So we can draw these just to say this line and that line are parallel, right? Let's move on to the next piece of information we get in the question. And it says, arc AB, right? So we have this arc is part of a circle with center O, right? So I'm just going to mark that circle. We have this arc, right? This is the center O, so that means this is the radius, right? So that's the radius, 15 centimeters. Which also means that to complete the sector, this is also the radius of the same circle, right? So the angle of that sector is going to be theta radians. And again, the moment you see radians, the moment the question says radians, it means you have to stop right there and change your calculator setting to radians, right? Make sure that it's not in degrees, otherwise it's going to cause you problems. So you're going to change calculator settings. I'm just going to write calc settings to radians. Make sure it's not in degrees, please. That's that's a step that you need to make sure that you are taking. Let's do this. Let's just move this to the side a little bit. All right, cool. Okay. So also let's just because we want to make sure we label this as much as possible, right? So if this is the radius, let's just make sure that we write the length of this line since we know it, right? So since this center O, this is a radius, this is a radius. So if both those lines are radii, it means they're equal. So it means it's going to be 15 centimeters as well. Okay, cool. So we have the information that we've written over there. Angle BOA is theta radians. We've already seen that. Arc CD, right, over here is part of a circle with center O and radius 10. So we're going to do exactly the same thing that we've done before. We mark that sector as well, right? So we have that line over here, that line over there, right? And then this arc over here. Let me actually see if I can. Oh, hey. Okay. I guess this will do. This will be fine. Cool. So this is also another arc with a center. The radius of that sector is going to be O, which means exactly the same thing as we did before, right? So if that is 15, it also means that this line over here is going to be 10 centimeters because this line is a radius, this line is radius, they have to be equal as 10 centimeters. And also we can see that this is pi over 2 radians. If it's 90 degrees, it's pi over 2 radians. If you want to do the conversion, you can always multiply, right? Because remember, to convert from degrees to radians, you're going to multiply 90 by pi over 180. 90 goes into itself once, it goes into 180 twice. Therefore, you're left with pi over 2. All right, cool. So, arc CD is part of a circle with center radius, so we now know that angle COD is half pi radians, which we have already deduced. So that is the information that we have. Maybe let's also mark the fact that if this line is 90, that means this one is perpendicular, right? Because remember, this line and that line are parallel. So it means whatever angle this one makes, it also means this one is also 90, right? Because if this is horizontal, this is perpendicular to that. If they were parallel, if they were perpendicular over here, they're going to be perpendicular over there. So this is also going to be pi over 2 radians. I think that's all the information that we can pick up from this question. So we've helped ourselves simplify the question going forward. So now let's look at the problem. Hopefully it's going to be easier as we work it out. Part A says, show that theta is equal to 0.7297 correct to 4 decimal places. Perfect. Let's go up. Right. Theta is going to be, theta is the arc of this sector over here. Usually, if it's a sector, maybe we're looking for certain information that we've been given. Is it the fact that we have, we can use arc length and then calculate the theta. We don't really have that. So what we're looking at is, because we don't have any arc lengths, any sector, areas of the sectors or anything like that. So what we'll use is, maybe let's use the angles and the lines that we've been given, right? Because we know that this line in total, from this line all the way up until there, okay, I'll leave it like that, that's fine. This is supposed to give us pi radians, or 180 degrees, right? Because it's a straight line. We know that this one is 90, or pi over 2. We don't know what this one is, and we also don't know what this one is, right? But however, with this triangle OBC, we do have two. We have this 15 and we have this 10. So just to make it easier, let's actually just redraw that. I'm going to draw that little triangle on the side over here, right? We have BOC, which looks like this, right? So this is this is C, this is O. We're looking for that angle, right? We don't know what that angle is, but what we do know is that this is 15, we know that this is 10, and we know that this is pi radians, or 90 degrees. So we can use trigonometry to work that out, right? With trigonometry, since this is the angle that we're focusing on, that means this 10 would be our adjacent, right? Since it's that's the line that's between the 90 degrees and the angle that you're focusing on. This one over here is one that's opposite to the 90 degrees, so that means that's your hypotenuse. If we're dealing with the adjacent and the hypotenuse, that is, according to Tor, that means adjacent and hypotenuse, it means we're dealing with cos. So what we're trying to figure out is angle BOC. So angle BOC is, in order to calculate that, we're saying cos of that angle, let's call it x, all right? The cos of x is equal to adjacent over hypotenuse, which is going to be equal to 10 over 15. Therefore, that angle x is equal to arc cos 10 over 15, which you can throw right into your calculator. Now remember, you have to make sure that your calculator is in radians. So I'm not going to simplify this, but I'm just going to throw it into calculator to see what you should get. The angle is actually supposed to be 0.84106. 107. But I'm going to leave it as arc cos 10 over 15 because we want to simplify at the end of the problem just to avoid rounding too early. So now what we now know is, okay, if the total of these three angles, the angle here, the angle here, and the angle here is 180 or pi, what we can do to find angle theta is we can say theta is now equal to that pi, or 180. Then you subtract this first one, which is pi over 2, and you subtract this second one, which is BOC, which is arc cos of 10 over 15. All right, because, or you could have written it like this. If I add up theta and that pi over 2 and that arc cos 10 over 15, right, I should get pi, which is 180. So that means in order for me to find this theta, I can take the other ones to the other side, which means it would give me theta is equal to pi minus this one and then minus this one as well, right? So that's how, in case it's confusing, that's basically what we did. In order to find the answer, you have to take the total, which is 180 degrees or pi radians, and subtract the other two angles that you already know. All right, so now we can throw this right into our calculators, right? We can go pi minus pi over 2. I am basically in the background trying to plug everything into my calculator, and the answer that you get if you plug and play, since they ask it in decimal places, is 0.7297 radians. Perfect. Got an answer that's different. If you plugged exactly this into the calculator, maybe it means that your settings are wrong, or maybe you made a mistake somewhere. So yeah. All right, cool. Now let's move on to question B. right? Question B is a little bit more loaded, right? It's a 7-mark question. So we expect to do a little bit more work here. The question says, find the perimeter and the area of the shape ABC. Give you answers to 3 significant figures. Now, the key thing here is don't just calculate one thing, right? So we have to calculate the perimeter, both the perimeter and the area, right? So let's jump straight into that. We're going to start off with the perimeter. The perimeter is going to be, let's actually just call it P. P is equal to the arc length AB, and we're going to add this line BC, and we're going to add the arc CD. Because remember, the perimeter of a shape is just the distance around that shape, right? So all we just need to do is just get, let me just actually make sure A, B, C, D, right? So it's A, B, C, D, and then it comes back around. So we also need to add arc CD. And then we also just need to add line AD. All right, cool. So let's get each of these, right? So in order for us to find the arc AB, the arc length of a sector, in order for us to get the arc length of a sector, it's always going to be S is equal to R theta, the radius of that arc multiplied by the angle theta, right? So what we're going to do is we're going to say, okay, in this case, it's going to be radius. Our radius is, we have radius multiplied by theta, which is in this case is going to be the line 15 multiplied by theta. Remember, your theta has to be the radian value. It's 0.7297, right? I'm actually going to use the exact value from my calculator in this case. So if I plug this into my calculator, I'm going to get 10.95. What is the unit? The unit is in centimeters. All right. So now we have AB. Perfect. Now let's go to BC. BC is, we don't have that. But what we do know is that we do know that it is part of this triangle over here, right? It's a right angle triangle, so that means we can use Pythagoras. Now Pythagoras tells us that the hypotenuse squared is equal to this side squared plus this side squared. So basically, 15 squared is supposed to equal 10 squared plus the line BC squared. So in order for us to find BC, that's equal to, so you send the 10 squared to the other side of the equation. So now you have 15 squared plus 10 squared. But remember, the BC had a squared. So in order to remove that, you have to square root both sides, right? Hopefully it's not confusing that I did basically 2 steps in one. Let me know if it is. So if you put that into your calculator, your answer is actually supposed to be BC. I usually like to get exact values. 5 root 5. Perfect. All right. And then the next thing that we want to do is we want to get arc CD, right? I'm actually just going to work that out over here. Arc CD, again, it's exactly the same formula. It's the arc of a sector, and we know that we're working with this sector this time. That's going to be equal to, again, R theta. So our R in this case is going to be 10. And this one is a bit easier because our theta is pi over 2. So this one should give us 10 divided by 2. That should give us 5 pi. Perfect. And then the line AD is just from here all the way up until there. And then we know that this one is 15, this one is 10, which means AD is equal to 15 plus 10. The 2 radii put together. That's going to be equal to 25. Therefore, all right, the perimeter is actually equal to 10.95 Actually, what did they say here? They said to 3 significant figures, so that's fine. We can use 4 significant figures here and then round up at the end. Plus BC, which is 5 root 5, plus 5 pi plus 25. And our answer is, plug that into the calculator. For this value, I'm actually going to put the exact value from my calculator and then just add the other ones. 5 root 5 plus 5 pi plus 25. The answer is 62.8 centimeters. All right. Nice. That's the perimeter problem. Now we have an area problem as well, right? So we're going to write this as A is equal to, right? So we have this shape consists of 3 different shapes, right? We have 2 sectors. We can find the area of those sectors, and then we have a triangle, right? So AOB, right? So we can find the area of sector AOB plus area of triangle OBC or BOC, and then plus the area of sector OCD. All right. Okay. So again, we're going to work those out individually and then find, and then add up all the answers at the end. So the area of the sector AOB. Now, remember, the area of a sector is equal to half r squared theta. Okay, so in this case, all we need to do is find, we have the radius. In this case, it is, for that sector, it is 15, right? So we're going to have, so our equation becomes half of 15 squared multiplied by your theta, which is 0.7297. Again, I am probably going to use the calculator version. I'm going to take my calculator, go all the way back to when I found that answer at first, and then put that answer into my equation exactly as it is, because I don't like rounding errors. Half r squared theta, that answer should give you about 82.1, or maybe let's write that as 82.09 centimeters squared. Okay, that's the first sector. Because it's the same equation, I'm going to jump to the other sector, area of sector OCD. That's half r squared theta again. So in this case, your r is 10 centimeters, your theta is pi over 2, right? So that's going to be r, which is 10 squared. Remember, you can only use these for radians, right? So you can't convert this into degrees and then start using these equations. These formulae only work with radians. That's half. Actually, just plug that into your calculator. So 10 squared over 2 multiplied by pi over 2. Our answer is 25 pi in this case, all right? Perfect. I'm not going to round it off at this stage. If we can get a perfect answer, an exact answer before you get to the end, write that, and then so that you, again, it's all about rounding errors, right? And then finally, we want to find the area of the triangle OBC. Now, OBC is a right angled triangle, right? Which has sides. We know that this side is 5 root 5. We know that this side is 10, I think. Let's just go back. Where is that 5 root 5? Because BC is 5 root 5, and then that side is 10. Why are these two sides important? Because remember, the area of a triangle can be half base times height. This is the easy, you can use sine rule, which is half BC minus sine A or something. No. Half BC sine C, half AB sine C, sorry. Okay, you can use that. However, it's as long as you have two perpendicular lines, you can use half base times height, because you can treat one side as the base and then the perpendicular side as the height. Because remember, with triangles, if this is my base, it means my height has to be this perpendicular height over here. So if they've actually done you the favor of already giving you a triangle that has the sides perpendicular, right? That means you can use this one as the height, you can use this one as the base. So that's exactly what we have here. We can use this side, the 10, as the base, we can use this side as the height, or we can actually just use the 5 as the base and the 10 as the height. It doesn't really matter. As long as we have two perpendicular lines, we can use that half base times height. All right, so let's jump back to the question. So we can use half base times height, which is equal to half of the base, which is 5 root 5, multiplied by the height, which is 10. So this is probably going to give us 25 root 5. 25 root 5. Perfect. Root 5. Okay, sorry. I want to close that. Okay, cool. Perfect. So now we have the areas of the individual shapes. So now all we just need to do is add, right? So that's going to be area is equal to the first one, which was 82.09, right? 82.09 plus the 25 pi plus the other area, which is 25 root 5, and all you just need to do is plug this into your calculator. These two exact values, so I'm going to take the exact value that I had gotten from my calculator for this, and I want to add 25 pi plus 25 root 5, and I get 216.5. And if we round that, because it's supposed to be 3 significant figures, right? So it's supposed to be 3 significant figures. Therefore, that's supposed to be 217 centimeters squared. Make sure this is centimeter squared. That's also centimeter squared. All right. So our answer is going to be 217 centimeters squared. Perfect. All right, cool. So that is how you solve this long problem. Now, I know this was a very long video, and our exam practice videos are going to tend to be this long because I really want to break down and slow down the question and be slow. If you are faster than the pace that we are going in these videos, that's perfect, right? Especially if it's towards your exam. If you're doing a lot of practice, I do expect that, it's expected that you start to be a bit faster. You're a bit more comfortable with the work. But the videos are going to continue to be slow because we want to make sure that we break down the question as much as possible, right? So hopefully that's not too much of a problem. But yeah, right, I'm going to end this here. Hopefully this was helpful. I will see you in the next video.